Hi, welcome to JUnit testing. I decided to basically go with JUnit's testing because this is used extensively out in the real world. And the reason I wanted to cover this is because as we start developing more complex classes, it really is tough to try to test every single little piece of that class, every method, every instance variable. Basically, how do we test everything and do it correctly? Well, this thing is called JUnit. Now, it says right here on this screen, this is the tutorials point website. It's a great website for all types of Java and Visual Basic and C++, so on and so forth. This is testing the process of checking the functionality of an application to ensure it runs as per the requirements. So we've developed this particular class to do a certain job. We need to make sure that it works correctly. So unit testing comes into picture as a developer's level. Okay, this is not at the tester's level, because the tester is actually testing actual code and actually putting data towards it. This is more at the developer's level. This is at our level, how we test it before we actually then basically start testing it with any type of data. It is a testing of a single entry, class or a method. Unit testing plays a crucial role in helping a software company deliver quality products to its customers. Unit testing can be done in two ways. It can be done manually or it can be done automated. Okay, so what is JUnit? JUnit is a unit testing framework for Java programming language. It plays a crucial role in test-driven development. Now that's another thing I'm going to touch on a little bit. There's a thing called TDD, which is called test-driven development. And then what we do is we actually develop the JUnit test cases first, and then we basically create the classes from that. So it's kind of like making sure these pieces and parts work before we actually develop the code. So which emphasizes on setting up the test data for a piece of code that can be tested first and then we implement it. This approach is like test a little, code a little, test a little, code a little. It increases the productivity of the programmer and the stability of the program code. So features of JUnit, we basically, it's an open source framework. We're going to see that it's basically, I believe it's included right in Eclipse. Provides annotations to identify the tests, so basically those comments, that basically those special comments allow us to annotate and basically provide input into this JUnit. It provides assertion for testing expected results, provides test runners for running tests, so allows us to run a specific method. That's it. Allows us to get to that one specific method and run it. JUnit's tests allow you to write code faster, which increases quality. JUnit is elegantly simple, it's less complex, and takes less time. You're going to find out that it's very, very, very easy to create a JUnit test case. JUnit tests can be run automatically, and they can check their own results and provide immediate feedback. There's no need to manually comb through the report of the test results. JUnit tests can be organized into test suites, containing test cases and even other test suites. So basically a suite is a combination of test cases. JUnit show test progress in a bar. It's going to show red or it's going to show green. So is a JUnit test case. A JUnit test case is a part of code which ensures another part of code, the method, works. So it's basically code that runs methods. Okay. So basically, what does it look like? Well, if I were to come out here to Eclipse, and let me just open up a, let me open up something that's, yeah, that. Well, let me just do this. So I can come into here to this particular item, and I can actually do a right click on the well, let me say this. The first thing that you really need to do is create a new package, a new folder just for this testing. So I come in here and I do a right click on the source folder, and I point to new, and I go to package, and I always like to just name them test. Okay, it's just simple as that, no big deal. Then when I have my test package, I do a right click on that. I point to new, and you're going to notice right down here I have a thing called a JUnit test case. So I click on it, and it comes up and says, what are you going to test? Well, if you notice, I'm in this was it dorm and meal plan.java. Well, I always like to just give it the same exact name, dorm and meal plan, and then add the word test behind it. And then now I can go ahead and do setup before, tear down after. There's some methods we can automatically create, and I'll talk about those in a second. And I can say, do you want to add comments, configure templates and default values here? So I can actually say generate comments, and then the class under the test, so I can actually click on this guy. Let me see if I can. There it is. So I just typed in DOR and it popped up. So that's the Java code I want to basically test. I click OK. I click Finish. It says, do you want to perform the following actions? Add the JUnit 4 library to build a path. Yeah, I want to have it go ahead and automatically bring in those pieces and parts that I need, kind of behind the scenes. Remember I talked about jar files. I go ahead and click OK, and when I get done, I now have this dorm and meal plan test. And if I look, I can see that I've got package test, and it says import static or.junit assert. If I expand this, basically it's got the import JUnit test as well. Here I've got my public class dorm and meal plan test, and here I've got my void test. Okay. So what it does is just kind of throws this generic method in here. You notice it's a class and it's a dorm and meal plan test. Okay, so basically it's basically how this is kind of neat. Is what it does. It says, hey, my name is dorm and meal plan test, and I'm going to well, let me just do this. I've got this check password class, and in here I have an instance variable called password, and then I've got a local variable called char array. Let me do this real quick. These need to be private. Okay, so I've got these two local variables. I've got one local variable and another instance variable. Okay. So here I've got my constructor, which is a string check password, and we're bringing in a password, which is a string, and I say this.password, so basically the instance variable is equal to that password. And then I go ahead and this array, which is a char array, I take this string and use the method that's built into the string class called toCharArray. Takes whatever string that is and basically takes each letter and makes it an element of an array. So when I get done with the constructor, I have my password, which is a string, and I have an array of letters from that password we just brought in. I have this method called isWriteLength. I set a Boolean switch called writeLength equal false, and then I step through that char array one at a time, and I'm checking to see, well, no, this time I'm not. All I'm doing is I'm taking the password itself, I'm checking to see that it's greater than or equal to 6. So one of the requirements of this particular password, it has to be greater than or equal to 6. If that is true, I go ahead and set this Boolean switch writeLength to true, and then I return the writeLength, because it looks like I'm right here, I'm returning a Boolean. So I initialize it to false. That means that if it's less than 6, it's going to stay false, and that's what's going to return as false. So if I call this method isWriteLength, and it is the right length, I'm going to get true back. I have isLowerCase. Again, it's returning Boolean. I have a local variable called lowercase. It's a Boolean. It's set to false. I go ahead and step through that char array one element at a time, and I check to see, I say at any time if that character is lowercase. So if the character I bring in, that one character, if it is a lowercase, I go ahead and set this Boolean switch to true. And then I return that Boolean switch. So again, it's going to return true or false. Is uppercase, same exact thing. It's going to go through that char array. If the character class, kind of going, I think it's back to chapter 9, if the character, it's got a built-in method called is uppercase, if that particular character is uppercase, it sets this Boolean switch uppercase equal true. And then I have this other method called isDigits. Again, it's stepping through it one at a time. If one of those characters is a digit, a numeric value, I go ahead and set that digit equals true. So I have these 4 different methods that are checking each character of that string of the password to see if, number one, first, is it 6 characters or more? Does it have an uppercase? Does it have a lowercase? Does it have a digit? Then I have this string called check display, and I create a disp message local variable, and I set it to null, and I say if not is right length. That means if that did not get set to true, I display the error. I put this string error, password must be at least 6 characters, into that local variable. Else if is uppercase, if not is uppercase, meaning there's no uppercase letters, it sets that particular item to true, or to that particular phrase. Password must contain at least 1 uppercase. If is not lowercase, same thing. If is not digit, do that. Else, I take that display message and say, great, the password checks out. And I return that display message. So whatever calls this is expecting a string back, and that's what it's going to get back. So how do I set up a JUnit test for this? Well, we saw how we can set up a JUnit test case. And think of a test case as just a JUnit class. So here it is. So here is my JUnit test, and you'll notice that one thing I've done is this particular password, it's in a package called code, and the actual class I'm using that I'm checking is called checkpassword.java. You'll notice I have import code.checkpassword. That says go to the folder or the package called code and basically bring back that Java code called checkpassword. So now we have access to that class file within this JUnit. And here's my JUnit.framework.test case. So here's my class. It is its name is checkPasswordTest. So the Java code's called checkpassword. This is checkPasswordTest. It extends a test case. So there is a test case class that I am basically extending. So I'm inheriting all of those features that guy has. I then go ahead and create a checkpassword object called CP, and I'm putting in this string text called BOBBY3. Okay. Now, if you look at that, the requirements for the password has to be at least 6. That's 7 characters. Has to contain an uppercase B, a lowercase, all those letters are lowercase, and 1 digit, and it contains a digit. So that particular item right there is basically a valid password. Okay. So I create a method called test_isRightLength. Now, basically what I've done is I've taken the method isRightLength and I've put the word test in front of it. Now, with all of these methods in a JUnit test case, they always return a void and we use nothing in the parameters. Okay? And inside there, I'm going to talk about these different built-in methods. These are built-in methods that are part of the test case class, and it's called assert equals. And the assert equals, I'm going to put 2 items in there separated by a comma, and I'm saying I want you to take this item and compare it to that item and see if they're equal. So this guy is expecting an equals these 2 objects to be equal. Okay. If they are, this will basically give a thumbs up. Okay. This is test is uppercase. Same exact thing. Assert equals. And I want to compare the actual item true to cp.isDigits. So it's actually calling that isDigits method. And again, remember, it's returning true or false. So if it's true and this guy is true, then we know that they basically worked, okay? That this guy basically passed the test. Is uppercase, same exact thing. Is lowercase, same thing. Then I have this void test check display. So if you remember, the check display is basically returning either an error message or great, the password checks out. So what I've done is I've created a variable called dispReturn, and I said dispReturn in this case is equal to great, the password checks out. So I then say string disp, so I create a variable called disp, is equal to cp.checkDisplay. So whatever this guy returns, okay, I'm going to go back over to check password. So whatever this guy returns, I'm going to receive it in this variable called disp. Then I do an assert equals, check to see if they're equal. So if what is ever in this variable is equal to whatever's in this variable, what got returned, this is going to return a thumbs up. Okay, so again, if you notice, I've got a valid password, so I'm expecting this to be true, this to be true, this to be true, this to be true, and great, password checks out. This should also return a true. Okay, so this is basically going to return a string, and this is going to have a string in it. They should both equal. If they do, it returns a thumbs up. So now here's what's kind of strange about JUnit tests. I won't say strange, but this is kind of the interface that they basically return. So when I run this, now this is executable. JUnit test cases are executable. It's like a main, public static void main makes it executable. Well, JUnits right out of the box are executable. So when I run it, over here I have this JUnit panel that pops up, and you'll notice I have a green bar. That tells me everything checked out. If I click on this expand here, this is the class check test.check password test, and it says this method got a green check mark, this method got a green check mark, this method got a green check mark, green check mark, green check mark. Now let's make it not work. So first thing I'm going to do is I'm going to get rid of one of the characters. So now it's 1, 2, 3, 4, 5 characters long. I'm going to then save it, and I'm going to rerun it. And when I do, you notice we now have a red bar. The red bar says either one or more of the methods returned a thumbs down. So if we look, we can see that check test display has an X right there, so it basically got returned. It returned something other than great, the password checks out. Okay, so what we can then do is look at that and figure out, okay, so I've got less than 6, so this message right here, now what I do is I've got all these messages in here, and I will include this code in the training, or I'm sorry, in the e-learning for that week. And I'm going to uncomment this dispReturn. So I say string dispReturn. I say dispReturn is equal to error, password must be at least 6 characters long. So I save that, and I run it, and sure enough, the test check display now has a green check mark. So it did return error, password must be 6 characters long. Now since I made this 5 characters, what I could do is come in here and change that to false. So now since that is only 5 characters, I'm expecting this method to return a false. So I'm going to compare false and what is returned from isWriteLength. So when I save it and rerun it, boom, we have green across the board. That method checked out, that method checked out, boom, boom, boom. So the check test display, it returned password must be at least 6 characters long. This returned a false. So as you can see, I'm not just trying to test it for good data, I'm also trying to test it for bad data as well. So let me do this. Let me change it back to 6 characters, and I'm going to change this b to a lowercase b. I'm going to save it, and I'm going to run it, and now we have 3 of our JUnit test case test item methods not work properly. The test check display, well, that's all lowercase. It is 6 characters long, so this is no longer the point. So I'm going to come down here and say it must contain at least 1 uppercase, which is what I'm checking. So let me save it and run it. Sure enough, test is right length it's false right now. Well, it's true. That should be returning a true. So that should be a true now. And I run it again, and sure enough, that now checks out. So it is returning. So when I call this is right length, that is basically returning a true. It is returning the right length. So I go ahead and set that true. So that basically is returning what I think it should be returning. Now, if I change this is uppercase to false and save it and run it, I'm expecting green across the board, and there it is. So now let's try this from a different approach. What I'm going to do now is I'm going to change this to all uppercase. So now what I'm going to do is I'm just going to come down here and say, okay, I'm expecting the error message to be returned is error password must contain at least 1 lowercase value. I'm expecting that. And I'm expecting the is lowercase method to return a false. So I change that to a false. Okay. So that should return a true. That should return a true. That should return a true. And let me change that to true. Caught myself. And this guy should return a false. And the error message that should come back is error password must contain at least 1 lowercase value. So when I save it and I run it, boom, I get green across the board. So everything worked as planned. So as you can see, this is not doing any kind of special processing. I'm not trying to throw some data at it. I'm not trying to do anything like that. I'm just taking a particular item. I basically throw it at it. It allows me to test everything properly, and everything looks fine. So let me do this. Let me change it to BOBBYS. I'm going to get rid of the 3. So now it's just Bobby's, which tells me I don't have that in there, do I? Ha 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 ha. Oh, no, yes I do. Password can be at least 6 characters long. Okay, so that's the error message I'm expecting. This should now be true, and this is digits should return a false. Okay. Okay, so I'm expecting this is digits to return a false, and I'm expecting this check display to return error password must be at least 6 characters long. So when I run it, check test display. I don't have the right error message in there. Ha 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 ha. Yeah, it should have this. Okay, so let me do this. I just caught that. Okay, so, wow. So now I'm expecting error password must contain at least 1 digit. And I'm expecting this is digits to return false. So I save it, I run it, and green across the board. So there is all of my methods returned what I expected them to return. Okay, so it's not, again, it's not rocket science. It's just a nice quick way to test our each method. Now what we do where I work is every single one of our classes has to have a test folder and a JUnit test for that class. Anytime we make a change to that class, maybe if I add or remove a method, I have to make sure I go in and add or remove that particular method that goes with that JUnit test case. So what that allows us to do is, if I make any changes, the very first thing I want to do is run this JUnit test case. Okay, and what it does is it basically makes sure that everything is working the way it should. The method does work, and again, as you can see, we can go in and change some things around just to make sure that it does work properly, the way it's supposed to. Or in this case, I can go ahead and change, cause an error, and I'm expecting this guy to return a false, so I make that a false. And I'm expecting this error message to be returned, so I change it to that error message, and basically voila, boom, it works fine. Green across the board. So what we're striving for here are green. If we get red, that's where we need to go in and make sure we figure out what caused it to go red, and do we have the code correct so that it does basically what we think it does. Okay. So kind of getting back to over here we have, so it talks about the local environment setups, so on and so forth. Let me get to some of the different so let's talk about some of the features. So the first thing we talk about is this thing called a fixture, and that is a fixed state of set objects used as a baseline for running tests. We have setup, tear down, so on and so forth. Now what setup does, we do have a method that's built into the test case class called setup, and what that does for us, allows us to set things up. That's kind of like a constructor for a JUnit test. It runs automatically. Okay. And so here we have a setup. We go ahead and set our values. Now let's basically do that same thing here. Let's go ahead and create a public void setup. And what I'm going to do is move this guy inside of there. Okay. Now the one thing you'll notice right off the bat, we now have some errors. And here's why. I created an object called CP. It's inside of this method. That means only this method can see it. So what I can do is basically do this. So now I have created this object called CP, and inside of the setup is where I instantiate it. Okay, so let's see if it works. Does that work? Voila, it does work. So here I create my object as a global. It's basically a class global variable, meaning that anything inside there can see this variable. And then my setup goes ahead and instantiates it and sets it up. Okay, so again, think of the setup as a JUnit test case constant. And again, that's the very first thing that is executed when we're basically running a JUnit test case. The next thing we have is called a setup, and we have a tear down. Now, what a tear down does is it's basically, when we're done with this JUnit test case, we make sure that we put that tear down as the last method. And what will happen is that will be the very last method that gets executed in our test. So if there's anything we need to kind of clean up, or anything we kind of need to to modify before we shut this down, we can do that in the teardown. So the teardown allows us to basically so it says it runs after the every last test method. Okay, so again, it runs after each method. So after each method runs, it calls the teardown. So let's say I wanted to okay, let's just do this. So I'm going to create a teardown. So public void teardown. Is that right? Did I spell it correctly? Yeah, teardown. Okay. So so there's my teardown, and I'm going to say cp dot I don't have a set. Let me try this. CP equals new so let's say so here's what I can then do is I can come in here and put this particular item here. Okay. Now I'm going to change that to an S. I'm going to change this back to a 3. So here's what it's going to do is right off the bat our setup puts Bobby3 with all of the right variables, all the right characters in this CP. Then it runs this test is right length and it's expecting true to come back. Then it executes the teardown, which goes ahead and sets Bobby3 back up. Okay, which it's already Bobby3, so it's not a big deal. Then I come into test digits, and that's where I change it to Bobby's, and I'm expecting the false to come back, and I'm expecting this to basically, well, that's not going to work then, is it? Because this guy is going to then return, that's going to return great, the password checks out, because by the time it gets to there, so let's see if that works. Let's see if my theory is correct. Right. So my test display is displaying, that's where it's blowing up on. It's displaying, great, the password checks out, but that's not what's basically happening. So, yeah, and the reason being is after this guy runs, that's false. That's fine. Then it hits the teardown sets it back to Bobby3, and great, the password checks out. That is what basically was displayed. So if I go back up here and do that, yeah, we have green across the board. Okay, so again, the teardown was ran after gets ran after every single method. Okay, so do you have to have a teardown? No, as you can see, obviously we don't have to have that. So teardown runs after every class. So in this particular case, I probably don't want to use teardown. I don't have the need to. So what I will basically do is, so that basically is what should run. And what do I go on here? So Bobby's. When does setup run? Maybe I'm wrong. Maybe setup, setup is run before every test as well. So yeah. So it basically did the same exact thing that the other class, or the other teardown did. Okay, so setup. Now there is a initial setup. Okay, we'll see it in just a sec. Okay. Because there is an initial setup and an initial or a final tear down. So there is a way to basically set that up and then tear it down as well. So we'll see that here in just a second. So so again, the test runner, when they talk about a test runner, we are talking about these guys right here. Test is right length, test is digits. Those are called test runners. So we have the assert, which basically contains a set of assert methods. We have a test case, we have test results. Okay, so test case class, test runner class. Okay, so let's go on here, and so a test suite is a composite of test. So test case, so an assert is a set of assert methods. Okay. A test case is a test case defines the fixture of run multiple tests. That's basically what we have right there as a test case. Test results is that's the collection of results So this red bar, that is a test result. Okay. And then a test suite is a composite of tests. Okay. So so here are some different methods that we can test with. Assert equals, we've seen that. I give it two things. It checks to see are they both equal. And in our example, I basically was calling a Boolean method. It returns a Boolean, and I put a true. I'm expecting a true back, and so I'm expecting green there. Assert false. That basically, now I could do this. I could change this to true, and I could change this to oh, did I spell it wrong? Assert false. Well, let's do this. I think what it's expecting is that right? No. Oh, come on. Oh, you can't use that. So let's do equals. Okay, well, let's do it your way. So I'm just going to do Boolean item equals true, and then I basically say does item equal what is returned, right? So what are you expecting? Oh, need one more. Okay, so now I'm asserting false. I'm expecting this to return a false. So when I run it, I should see a green. Yes, and I do get that. So my isDigits is returning a green because I'm expecting this item to be true. And let me do this. So I'm expecting this item true to basically, which contains a true Boolean switch or Boolean item. I'm expecting this guy to return a true. Well, I'm asserting it false, so I'm expecting that to not be true. And so that basically is what basically happened there. So assert false. So I can add, now, as you noticed, with the assert equals, I give it two parameters. With assert false, I just have one. And basically, I have a particular check of something. So I'm expecting false to basically be in there. because again, when I basically say item, this item equal that item, it returns a Boolean, which is in this case a false. I could actually do this. I could actually put the word false in there, and if I run it, that returns a green check mark, which is basically true. Okay. Assert not null, I can give it a object, and if it returns a null, then it's going to have an X there. It's going to basically be red. So I can assert null. I can assert not null. I can assert null. So I can actually check to see, am I getting back a null object? Am I not getting back a null object? I can assert true. So it's just like assert false, but I can assert true. So in this case, I can do this. I can say assert true. Well, I can say assert true, and I'm going to put Bobby3 back in there. So that should return a true. I'm going to check it to be equal to that variable, which is a true, and so I'm going to assert it true, see if it returns, and sure enough, it does return a true. Okay. And then void fail. Basically fails a test with no message. So basically, if the test comes back or the test fails, I can basically then do something. Okay, I can display a message, whatever. I can, yeah. So I could do something like this. I could say if so let's see, I can say fail. Is it fail or fails? Yeah, fail. One, two, three. Oh, I know what I did. Okay, so if it's be aligned by itself. Let's see what it says. Remove. Oh, it just says if fail. Okay. What are you barking at now? Oh. So it's going to return of, so okay, I see what they're saying. So anyways, we can just basically just test for a fail. So I can actually have a method, just have fail in there, and if that's green, then I know it basically failed. So I could actually do this. I can actually say public void test is up. Well, let me just duplicate this guy. I can't have two methods with the same name, so let me just call it test uppercase fail. And I'm just going to say fail and a semicolon. Okay, so now this should return a green check mark. Okay, if when I call it, it fails. So, but in this case, it's going to basically work just fine. So that we should get a blue X here, showing that basically didn't work. So when I run it, sure enough, test is uppercase fail, return that. So that's kind of another test we can do. If it fails, let's have a test for that. So I just tested to see if it failed, and it didn't. So that's kind of a double negative, you know. I want to test to see if it failed. If it fails, that's true. So it's mind-boggling. So again, this is a way to see if it failed. So I'm going to basically comment that guy out. Okay, so assert equals, assert false, assert not null, assert null, assert true, and just plain old fail. Okay. Here's some different classes we have. We have a count test case. It counts the number of test cases executed by the run. Test case create result creates a default test result object. So this is actually a class test result, and I can create an item from that. Get name gets the name of the test case. Test result run. A method to run the test. Anyways, I don't want to set up tear down and then string to string. So here we've got, here's our setup. So this runs before every test. A tear down actually does nothing. And here's a public static void main, and then for failure, apparently there's a class called, is this failure? Yeah. Result get failure, okay. So some other methods we have are add error, add failure, and test, error count. Again, I don't want to go into all these. What we've covered is really what I want you to get out of this particular item is how to test a class. Okay, how do we just test the class? Maybe the class has some calculations that it does. I might feed it a couple of numeric values, and then it basically comes back with some type of a calculation. Yeah, I don't want to go into all these other ones. So really primarily what I want you guys to come out with is the oh, I think I passed it. Oh, I can't find them now, so let me, yeah, so really this is all I want you guys to really focus on is the assert equals, the assert false, the assert not null, null, assert true, and fail. Those are really, and the biggest one here is probably assert equals. That's probably the biggest one we're going to utilize. So other than that, that's really all we want to do at this point for testing. So again, if you have any questions, make sure you give me a call, give me a yell, and we'll basically get those answered for you. See you next time.